Hi, this is Jeff Allen. Hi, Frank. This is Jeff Allen. I just want to respond to your LinkedIn post about the emergence of multimodal models for revolutionizing industry-specific AI for by going that goes beyond text-based task. And actually, this has been around for a long, long time because 25 years ago, yes, 25 years ago, maybe 26 now, I was the technical director, CTO of the European Language Resources Association and the distribution agency, which is based in Paris. And what they do is create databases, linguistic databases of text, of audio, and of terminology of at that point, at that point in time. And then what they do is you produce these databases. Have to go out and actually go into certain situations like in vehicle recordings. So what I would do is go out with teams, and we would go on 9 different languages, sponsored by the European Union, and European Commission. We would do recordings. We'd create a context, create a bunch of scripts and things that people could read while they're driving in different driving environments with different situations of windows down, air conditioning on, driving speeds different, men and women, half women, half away, different age groups as much as possible, and create these little scripts and numbers and place names and nonsense words that they could read, just single words, single sequences of letters or numbers, and like pin codes for your phone, and all kinds of little things like that. That was based on, we have to get about 5,000 people to participate. You have to incentivize them to actually participate in this project and do it about 2-3 years. And you create this long, huge database of, that has recordings from going over the phone lines and 2 different phone lines, two different servers in the car, to be able to create a database that we could finally be able to create to use for speech to text based systems or speech based systems of mobile phone operators, to be able to understand the voice in a car in different environments. And that's what makes our phones better today, to be able to understand when people are driving a car, right? So it helps to create, noise filters and all that kind of stuff, and better speech recognition. And that was a project 25 years ago. Then we did like in-home appliance. You'd have do a recording in a home, and you'd be doing all these words and things to be able to talk to your different devices across the home, right? And so their projects do that as well. So that was the SpeechDat project, SpeechDat car. So that's kind of one example. But then a lot of it's speech-driven, a lot of it's audio-driven, a lot's text-driven, and then they are still around today. It's elda.org, elda.org. They have all these databases, and which has really taken off due to the whole finally AI has become something more than text, right? And there was a lot of text. We had a lot of text stuff when I was running the place there, doing a lot of production projects and promoting them and getting out and creating new ones. And so finally we're getting to a point, and you're right, where we're getting beyond just the text. A lot's been based on text because text is an easy code to understand, right? A language text, human language text, because let's say 1,000 of the 6,000 languages today, 7,000 languages and dialects today have a spelling system. Okay, so what happens is that written text, that orthography spelling system for those 1,000 languages, only those 1,000, allows for it's a universal within that language in general, but there are lots of languages that have a lot of spelling variants and a lot of different spelling systems. So I don't want to go into that because that's my background, so I know that really well. But then going into different data types. So audio is an obvious one. Audio and voice, I mean, they're the same thing. It's just two different inputs out. I mean, they're both the same input. It's just how you use the output, right? So but using voice to speak and then listening, right? So they have different reasons to be, but they're based on the same type of same mode. Okay, video is a combination. So video includes the voice or sounds, and then has includes the visual aspects to be able to see, and then of course vision is another one. So these are vision recognition, image recognition, voice recognition, and you can go text to speech, speech to text, and you can go, the visual one's a little more difficult because images, especially when we have text on images, that's always been a really big challenge. We get text that's integrated into images. So that now we're getting to the point where we can actually extract that. Not extracting so much to be able to when we have a text, they have like a phone, it can capture the text and reproduce it, and then through OCR, basically the OCR kind of technology is more advanced than that, and then be able to reproduce it and then spit it out as a text, right, and then process it. So we got a lot happening there. We're not quite. I mean, when I was invited to Microsoft for my Microsoft research lecture in 2010 to talk about how to put low data languages up into online translation portals. I was discussing the different needs and things, and one of the things we were not at that point, and we're still not today, where we can do audio to audio or voice to voice conversion. It's called translation, but conversion. We're not there yet, far from that. And the reason for that is because when you've got like a language like German, you got a language like Korean, be able to convert the Korean phonology, which is beyond phonetics, it's the language itself and all the meaning that's in it, into German phonology or phonemics. You've got a lot of different kind of ideograms and how the processes happen. So you can't just go voice to voice. You've got to go through the meaning, and the meaning usually you have to go through. The way to do that and shortcut that is going through text. So German, going through Korean, speech to text, then text to text from Korean to German, and then going from text to speech for the German, and going back the other direction. And I've worked on these a lot of systems. So that was in my background before I even came to SAP, and I had that part of SAP. So this. Our goal, the holy grail, is to finally get to voice directly. That's tough. It's really tough because of the things I just mentioned, and it's kind of complicated. I don't want to go through all the details here. But we're doing a lot. We're seeing a lot now in video. I'm even doing some projects here at SAP about using speech to text and text to speech with videos, and seeing how we can do all kinds of new things with these types of different multimodal approaches with different software to make it do it. So it's pretty cool, and it's finally getting traction. Let's say it's been around for a long time. The multimodal approach has been around for a very long time. It's just that it didn't get the traction until we had the Gen AI hit in November 2022. That's really to make it take off. But it's been around for quite a long time. That's why the European resource, the ELDA and ELRA, were created in 1996 by the European Commission to create the databases, linguistic data warehouses, basically linguistic language resource data warehouses do that. But then it's got like the University of Pennsylvania in the United States has the Linguistic Data Consortium, LDC, that does the same thing. And there are other kind of these warehouses that exist. But they just need funding, and it's really expensive to do these projects. And then they sell for a lot. And you got to do industrial research. You have different pricing for if you're academic, industrial research, and if you're commercial needs and all that. And it's a long process to create these and to create good data, right? There's a lot of polluted data out there, which is useful. It's useful to have the polluted data, scraping the internet and all that. But the difficulty you're going to run into in using broadcast, kind of TV broadcasts and audio broadcasts, is there a lot of polluted data in that too. Well, not polluted. It has a lot of what we can call errors, and that creates a difficult thing because you have to do error cleanup, and then you want to use the errors later if you can identify them, or create error-based databases to be able to deal with the content that doesn't always follow the rules, right? That the grammar rules or spelling rules, or what do you want to call these things, or speech pronunciation can be very, very variable. So this is a challenge, And that's kind of the great thing of having these data warehouses, I'm going to call them. But individual companies or organizations, governments can't spend the money themselves, though they want to have kind of specific ones. So there are these different warehouses that exist, or exchanges. They're attempting to have exchanges between different organizations too. Those haven't always worked out because data can be very specific to a certain corporation or government, but you want to train it up in a lot of common stuff and then common data, and then be able to make more specific to that organization. So, a lot to say about that. I'm just trying to cover it in 10 minutes, and there's so much to cover. But just saw your post, and I thought it was quite interesting, and what it's moving towards now, where we can make this more applicable to certain industries and businesses. So, thanks for listening.